Recorded. Get things started. That kind of goes right into one of the things I want to start with.
Okay.
So the plan for today is to take any other homework questions anybody has. Then I want to focus on the word problem kind of stuff that I went over a little bit before, but I've actually got a worksheet up on Canvas devoted to this that we're going to look at together. And then we're going to talk about, as promised, we're going to get into factoring and looking at the synthetic division that I teased and the long division that we did, right? Long division of polynomials. Sounds exciting. So anybody have any questions? Any more questions? I've got a few that I held on to until class started. That's right. I got to keep an eye out too. I got to make sure none of you guys are actually taking the quiz right now. I'll let you guys think about that. No questions? Everybody's good?
I was also having a little bit of trouble finding the equation from a given graph that was quadratic.
Oh, do you know which number that might be?
I think like 42. I'll check real fast and get back.
Yeah, sure. I want to make sure what the instructions were. I think I know. Was it the one that gave you the vertex and a point? Let me see. Like number 26 through 33 in 5-1? Oh, I got to
think it was like 41 through like 50 somewhere, I think.
Oh, okay. Let me take a look here. Oh, that's right. They give you the graph. Ooh, I like it. Okay, so let's look at one of these. All right. Bam. It's sort of like, it's exactly the same as these. Because from this graph, you could see the vertex and you could pick out a point, right?
Yeah.
So what version, how many equations, somebody was asking about the number of questions in the quiz. I can't remember right now. I'm sorry. How many equations for a parabola do we know right now? Or for a quadratic? How many versions of that do we know?
2, I think.
Sure. Yeah, 2. Do you guys remember what they are?
A x squared plus bx plus c.
Kick ass. And then the other one, I'll give you a clue.
A times x minus h squared plus k.
Kick ass. All right. Now, which version can I use if I know the vertex?
The second one.
Second one. All right. So like this problem, for example, what's the vertex of this problem here?
2, -3.
2, -3. So I know that h is 2. So I can write this as y equals a times x minus 2 squared. And I know that k is -3. All right, let me stop. Is everybody with me? So what's the only, so real quick, I don't think I've used this word before. Numbers like this, a, h, and k, they are officially called parameters. They are more special variables. They change, but they change from parabola to parabola. For a single parabola, they stay the same always. So they're not really variables, but they are called parameters. So what's the only parameter I don't know with when I plug everything in from the vertex? I only don't know this guy. So how in the world can I figure out what a is? Is there any more information I have about this parabola? Do I know anything else about this parabola sitting right here? No? You're all like, I don't know what you know, Jeff. Well, I'm sorry. That's a good point.
Stretch.
Does anyone out there? Is that, yes?
I said it does not stretch, right?
Oh, you're overthinking it. Something more direct.
Y-intercept,
Yes, good. What's the y-intercept?
0, 1.
0, 1. Don't I know what x and y are in a specific instance? So if I plug those in to this, can't I figure out what a is? Are you guys understanding? Will a, whatever a is, will it change if I plug a different point in? Of course not, right? Are you guys with me? Whatever a is, it will stay the same. So whatever point I see, besides the vertex, because I've already used that information, right? So then I would plug in here, y is 1 when x is 0. And now look at that. That is beautiful. Can you solve that for a all day long, right?
All right. All right. That makes sense now.
I like it. I like it a lot. Okay, okay. You guys ever, when you find the equation of a line, how many of you guys like plug stuff in and solve for b when you're trying to, you guys know what I mean? Instead of using y minus y1 equals mx minus y x1, how many of you guys plug stuff in and solve for b? Does that even make sense to anybody? Does anyone do that? Do you guys know what I mean? Are you guys there?
Yes.
All right. So let me show you what I mean real quick. Stay with me now, because this is kind of interesting. What's the general form of a line?
Y equals mx plus b.
Holy shit. So how many parameters are there?
2.
2. So I only need 2 pieces of information. For parabola, I needed h and k. That's 1, 2 pieces of information. And then I needed a point. That's 3 pieces of information. Why does that make sense? Because there were 3 parameters in the equation. Is that not cool? If however many things you don't know, you need the equivalent amount of information to figure those out. All right. Now, so for this line, if I told you it goes through the point 4, 3 and 2 negative, it doesn't matter, Jeff. Just put, there you go, buddy. Right, you could figure out, just go with me for a second. You can figure out the slope. Woo, the slope. 3 minus negative 3 is 6, and 4 minus 2 is 2. So I get a slope of 3, right? Is that cool? And then I could do this. I could put 3 in there, and to figure out what b is, I can choose either one of these. So let me choose this one. I would put y is 3 and x is 4, and then I can solve for b. That's what I mean. Do you guys understand?
Yeah.
Same idea for what we just did to figure out a. It's the same idea, right? Using one more piece of information to figure out the last remaining unknown. Okay. All right, how's everybody doing? You guys all right? Remember, if math is giving you trouble, try coffee.
Your mug was part of the background.
Oh, shit. Oh, yeah, you're right. Try a mug that you can see. Okay, sorry. This is an appropriate size mug, by the way. Yes. All right. Anything else, guys? Any other questions? I got to remember the ones I said I was going to do when class started. Shit. So we got the word problem thing I'm going to do in a minute. Was there something else I was going to do when class started? I can't remember now. Shoot. Oh, well. All right, Jeff. Too bad for you. Anything else? Nothing else? All right. So let's do this. I want to discuss. Let's start with this. Oh, let me do this too. I got to make me it's all about me. There we go. If you go to Canvas right now, let me show you where this is. If you go to Canvas right now, you will find in the Unit 5 module, you'll find this function writing. So open that bad boy up. Okay, okay, okay. Let's go ahead and open that up. We're going to work on this together real quick. I don't want to take a ton of time with this. Now you guys got to give me a second here. Jeff, why didn't you get this ready before? All right, I'll be all right. Save as. Hold on. Hold on to your butts. Okay, here we go. Kabam. I like it. Kabam. So let me open that back up. All right. So even if you're not able to get to Canvas right now, you can follow along. As the semester goes on, I see that fewer and fewer of us want to have our cameras on. I understand. You're fine. I just feel more and more alone. It's okay. It's just a part of the condition. So look at this. Oh yeah, I promised to do, that's right. It was one of the word problems. Whoever was asking me, you're going to remind me in a minute what that was. So you have 40 feet of fencing to enclose a rectangular space. Right there. All right. So this is really huge. This is the way I wish I had been taught this shit. So please take this from me, please. These kind of problems tell you something. They just tell you. What is it? I already know what they told me. What did they just tell me straight up? Oh, thank you, Jordan. All right, I'll come back to those. So somebody help me out.
It's a rectangle.
Sorry?
It's a rectangle, I said. So one side is a bit bigger than the other.
Well, we don't know that. Could be a square. Square is just a special rectangle.
Yeah, true. We got 40 feet of fencing also.
40 feet of fencing, so that relates to the what of the rectangle?
The sides of it.
True.
The total length.
There's a length and a width though, right? So I think I know what you mean. It's the perimeter.
The perimeter. Yeah.
There we go. Okay. I love you guys. Doesn't relate to the area at all. Fencing encloses an area, right? So I have 40 feet of fencing. I'm going to use all of it. That's what I normally remember to say. So I know this is 40 and the perimeter. Now I've got to set up my variables. What variables do you guys want to use to denote my rectangle?
X and Y.
Sure. So we'll use X and Y. So what's this formula that relates to what they told me? What formula relates to that?
2x plus 2y.
Craziness. All right. So that's what they told me. I know this is true. Can you guys immediately see that I can divide everything by 2? Isn't that nice? You're like, sure. Now, what do they ask me? What do they ask me for? Sorry?
Write the space as a function of width.
Write the
Area.
area.
Right.
All right. So what is the formula for the area given how I've set up my rectangle?
xy.
XY. Crazy. Now, can you guys see technically from the way I drew this, which variable is the width?
Y.
Y is the width. The width is normally considered to be, generally considered to be this shorter. So the way I've drawn it. So now listen. What is the area currently a function of? It's a function of width and length. I want it to be a function of width only. So what letter do I want to get rid of?
X.
X. All right, so everybody's still with me. So what I can do, can I solve what they told me for X? Can I get X by itself? Of course I can. What do you get when you solve for X? What do you get when you solve for
Y
X?
plus 20.
Huh?
Y plus 20.
Well, no.
Y plus 40. Or no, X equals 40.
20 minus y.
That's wrong.
Yeah, it is. So how do I get X by itself? I want to get rid of the Y. I got to subtract Y. All right. You guys are overthinking things. So you see this? You see this right here? This here? Forget about it. We wrote the same equation in a better form, didn't we? So that's that 40 equals is gone. Does everybody understand that? I wrote an equation that captures that idea in a better way. So that idea is gone. And all I want to do is take the equation I have now and solve for x. So I just got to subtract y. What's happening? Okay. So now what can I do with this? This always reminds me of Invasion of the Body Snatchers. This is going to go in and it sees x and it's going to say, let me replace x with this pod person. Let me put this pod person in. Because what the hell is x? Can somebody tell me what x is in this problem? Don't say length. Yeah, x is 20 minus y. So anywhere I see x, I can replace it with 20 minus y. Now is my area a function of width only? So excited.
Yeah.
Yeah. All right. And then I can do one more thing. I can make this 20y minus y squared. What kind of function is this?
Parabola.
Parabola. So would it have a maximum or a minimum?
Maximum.
Maximum. Why would it have a maximum? Sorry?
I think it's minimum because it's not, we can't see the minus.
All right, now listen, you gotta be careful. The minus means the parabola opens up or down.
It's down. If I have a minus, it's down.
So if it opens down, does it have a minimum or a maximum?
As a maximum.
Maximum.
Maximum. Yeah, it's got a top of a mountain instead of the bottom of a valley, right?
Oh,
All right,
okay.
so there would be a maximum. So I could ask you, now let me stop right now. Did I majorly lose anybody on the path to getting here? You can even private message me if you don't want to let other people know for some reason you got lost. Okay, nobody's saying a word to me, so I'm going to assume everybody's with me. So in the book, what they're going to ask you is they're going to give you this, and then there's going to be one more sentence. It'll be a question. It'll say, find the maximum area, or I guess it'll be a command. How would I find the maximum area of this? I would just have to find the what?
Vertical.
Say again.
Vertical.
I know what you mean, but what is it?
Vertex.
Vertex. I like it.
Vertex.
Vertex. Kick ass. And what's the shortcut to find the vertex?
Minus b over 2a.
Yeah. So if I do, what's b? See if you guys can see. What's b?
20.
20 is b. Oh, man. Why am I using the crappy? Because you're crazy, Jeff. All right, sorry. I'm using the crappy write them up thing. Yeah, so b is 20 and a is -1. So then I get 10. And if y is 10, what's x? If y is 10, x is 10.
Mm.
So this kind of makes sense. What rectangle always has the largest area given a certain amount of perimeter is a square. That's kind of nice. That kind of makes sense. No? If I have a very, now watch, stay with me. I'm overdoing this first problem. I just am because I can't stop myself. So if I have 40 feet of fencing and I put 5 here and 5 here, how much is left this way?
As 30.
30. So how much goes just on each side?
15.
15. What would the area of this be?
$75.
This is feet, by the way. Yeah, so 75 square feet, right? So what about the answer I got? 10 by 10. What's the area of this?
100.
100. So it's obviously more than this. So as you change this and make this go up to 6 and this goes down, the areas will slowly approach 100 feet. And then you start making it wider than it is long, and it starts going down again. So it's really kind of neat. A square maximizes the area for any four-sided, well, I gotta be careful, for any rectangular shape. All right. I went way farther than that question needed us to, but I just wanted to, just because. All right, I'm going to clear all that, and this time I'll use the correct drawing tool. All right, this is all going to go away. Here it goes. You ready? Here he is. All right, bye stuff. Okay, so let's use the right tool. There you go, Jeff. So what's different in number 2? Number 2, this is kind of like the one we did earlier in the book. I don't know if you guys remember this, but this time I've got a piece of fencing running down the middle. So if I call this Y, then that means this is Y and this is Y, and then I can call this whole thing X. So this time the 40 feet goes into what, so let me do this. What do they tell me? I got 40 feet of fencing, but what's it go into setting up now? Not just 2 widths and 2 lengths. What's it go into now?
2x plus 3y.
Yeah, 2x plus 3y. And they're still asking me for the area. And the area is still x times y. Is that cool? X times y. So I still do the same thing. I still have to take what they tell me and I have to solve to plug into what they ask me. So I got to solve that bad boy for x. So if I solve this for x, let me see if you guys are with me. I'm going to subtract 3y. No, Jeff, you can do it. And then I'm going to divide by 2. Is that cool? And then I take that. I use what they tell me in what they ask me. It's very subversive. That's why I love the invasion of the body snatchers. Let me replace the X with this. Ah, it's some pod person. Looks like Bill. Hey, Bill. Ah. If you've never seen the movie, you have no idea. I'm sorry. So then area would equal 40 minus 3y over 2 times y. Is this still parabolic?
Yes.
Yeah, of course. Once you multiply it through, you'll get a y squared right there, right? You can still identify A and B. You can still figure out the vertex. It's not going to be as pretty. It's got some gross numbers, but oh well. So that is the area as a function of width alone for this more complicated setup. How did I do it? Drew the picture, identified the variables, wrote the equation of what they told me, wrote the equation of what they asked me, and then used what I know in what I don't know. When does it work like that, Jeff? When? Always. So that's how optimization problems work. When they say find the maximum profit or find the minimum area or whatever. All right, here's one that's a little more interesting. And then I think I have one that's different from these two that I want to look at. I don't want to spend too much time. How much? See, I've already spent a lot of time on this. Let's see if we can do this a little quickly. Oh, all right. No, you can't be. All right, now listen, if you take this equation, just take a minute and solve for x. That's all. You just solve that equation for x, right? How would you solve this equation for x? What would you do first?
Subtract negative 3y.
Yeah, I would subtract 3y first, and then I would divide by 2. So I just kind of did it because I'm used to these equations. So I have to show myself all the stuff. Is that all right? Somebody was chatting at me. They weren't sure where that came from. Oh, shit. Did I just do the same thing again, Jeff? Are you kidding me with this? No, okay, good. All right, sorry. So let's look at number 3 real quick. What do they tell me? Oh, let me get rid of that thing over there. So what information do they just tell me? Oh, this is a little bit stranger.
Has
Well, let's draw the picture. I'm sorry, go ahead.
Has X length and H height.
Yeah, they actually give me the variables I'm going to work with. So let's see, a rectangular container with a square base. So the base is square. It's got a length X, so it's got a width of X also, and the height is H. Is everybody with me? It's to be made from 1,000 square feet of material. So this is the 3D equivalent of what we're just doing. Now, I really want you guys to get this. Let me add in a little bit of 3D stuff. Here we go. What does this make? The 1,000 square feet. What does that go into creating for this?
The container.
Be more specific. What about the container?
All the sides.
All the sides. Good. And it's an area, isn't it? Because it's square. So what's the, so they tell me the total surface area. They tell me that that's 1,000. Now, what's the surface area of this? And then people kind of turn off when they hear that shit. But can somebody tell me what the area of the bottom and the top are?
2x squared.
X squared. So I got 2x squares, right? The top and the bottom. Is everybody with me? Don't make more of this than it is. I've just got a bunch of rectangles, right? Some of them are squares. What is the area of the sides?
XH.
XH. And how many of those do I have?
4.
4 of them. I love it. Is everybody cool? Did you guys see that? Not that hard. Not that crazy. You do have to draw 3D, and I suck at drawing. So if I can draw it, you can too. I like it. So that's what they tell me. They tell me this. And immediately, do you see how I can cut everything in half? So I go ahead and do that. Do you guys see that? I can just cut everything in half. Now that's a better equation already. Now, what do they ask me for?
So for the volume, it's asking
Volume. And what's the volume from the picture? What's the volume of this container?
2x squared. Oh, x squared h.
X squared h. I love it. Length times width times height. And they want me to write this as a function of x. So what letter do I want to get rid of in what I have so far here?
EH.
H. Can I use what they told me to get rid of h? What do I do to this to do that?
Subtract x squared.
All right, so don't be too specific. I solved that for,
Factor.
multiply by h.
no. I really want you guys with me. I want to kill h, which means I need to replace it with something, which means I have to take this equation and solve it for h. Isn't that what we keep doing? Whatever letter I want to get rid of, I solve the first equation for that letter. Maybe? No? So if I take that equation and I solve it for h, can't I replace h with what I solve it for? I don't know why you just put an X there. I don't know what that means. Do you guys at all with me? No, just, we've already done it twice, but let's see. If I solve this thing for h, I'm going to subtract x squared. Then what do I do to get h by itself?
Divided by 2x.
Divided by 2x. So that's what h is. So I can take this and I can plug it in there. Isn't h going to go away now? I can't write. Y'all know that. Get out of there. Okay. What am I doing putting a 2 there? Nobody knows, Jeff. All right, here we go. 500 minus x squared over 2x. So I just took h and I replaced it with h. Does everybody understand what I mean? Because that's what h is. I just figured out that h is this. So what is my volume a function of now? How many variables is it a function of?
Just x.
Just x, and that's what they wanted. Now, to be honest, this would not actually be quadratic. We actually could not do a maximum question for this problem, but I didn't care because I'm not asking you to find the maximum, right? So the only kind of things we can handle in pre-calculus without a calculator is quadratic. One thing you learn in calculus is how to do a max and min for any function ever, which is kind of a step up, right? But right now we're just in pre-calculus. We can only handle parabolic stuff, right? Okay. I don't know if that helped you guys out at all, but okay. All right. I'm going to stop sharing that. Okay. I don't know. So if you break it down into focus on what they tell you, right? The equation for what they told you equals the number. Then write the equation that they ask you, because a lot of mathematics is all about breaking the problem down into manageable parts. The people that are really bad at math overwhelm themselves thinking they're supposed to just spit out the end result. I'm like, how the hell do you get to the end like that? You can't do that. That's why you're going insane. You have to break it down. All right. So next thing I want to do, let me see. There was where'd it go? Number, let me see which one of these, 66 and 75. Let me see if those are, I think those are like the ones I just did. Yeah. 75, there's a different one. Okay. Let's talk about, I think this is the only different one, 75. So let's look at number 74, of course, because I don't want to do your work for you. All right, let me see if I can't do this real quick somehow. So the stadium holds 62,000 people. If I set the ticket price at $11, the attendance has been 26,000. So right now, how much money are they making? What's their revenue? Right now, before they make any changes.
11.
So the tickets cost $11 and they have 26,000 people coming. How do you figure out how much revenue they're making?
Just multiply them.
Yeah, just multiply. So what's 26,000 times 11?
$286,000.
No, I think it's 286, right?
Oh, okay. Yeah.
Okay, cool. I never, you never know in my brain what it's going to do. All right, now, so is that cool by itself? So obviously, to get the revenue, I would take whatever the attendance is times whatever the cost of the tickets are. That just makes sense, correct? Now watch this. When the price drops to $9, the attendance rose to $31,000. I mean, I'm sorry, 31,000 people. So if now watch what this means. All right, this is cool. How much then, if I say X is the dollars decrease for the ticket price, right? How much does the attendance change for every dollar decrease? Could somebody figure that out? How much does the attendance change? So how big of a decrease did I do? $2. $2. how much did the attendance go up?
By 5,000.
5,000. So on average, how much does it go up for every dollar increase?
2,500.
Yeah, I'm sorry, decrease. Yeah. So so for every X dollars in decrease, the attendance goes up. What did we just say? I actually just forgot what the hell I'm talking about.
2,500.
2,500. Thank you. All right, we stop right here. Let me stop right there. Is everybody with me? I'm sorry. One other thing. This is specifically for $1. So for every X dollars, the attendance goes up 2,500 X. So let me make sure everybody's with me. The attendance changed, went up by 5,000, correct? And the cost went down by $2. Therefore, it's 2,500 for attendance for every $1. So for X dollars decrease, the attendance will go up by 2,500 X. So now watch this. So that if I take the cost of a ticket and I make it 11 minus X, what will the attendance do? So if I make the cost go down by X dollars, the attendance will be 26,000. How much will it change by?
Plus
500.
Plus 2,500X. So this is what it was when I didn't change anything. Now the cost is 11 minus X and the attendance is this. How do I figure out the revenue now? I do the attendance times the cost. And of course, once I FOIL this out, what kind of function will this be? What kind of function will that be?
Quadratic.
Quadratic. And then you can find the vertex and it will be opening down, right? Because the X squared piece will be negative. So there will be a maximum. There will be a sweet spot revenue. All right. So that should help you on number 75. 75. It's actually a little bit nicer because the numbers aren't quite as crazy, but it's exactly the same idea for 75. Okay. So that's the last few problems in chapter 5. Now, I'm going to get into some new stuff. All right. I'm going to stop sharing this. You guys ready? It's going to go away. Okay. Let me turn off Jupyter. Okay, so what we're going to get into now, I want to build up to the point where we're talking about division, long division, so we can talk about synthetic division. To do that, I want to show you why it's important to know how to divide. Let me see real quick. Here we go. All right, so I want to talk a little bit about what we can tell about a polynomial if it's in factored form. I know, hold on. As motivation for us to want to get it into factored form. All right, get over there. Okay. Here. So if I have a polynomial, actually, let me do this. Let's start off really basic building blocks. What is the main difference between x squared and x cubed? The graphs of those. I'm curious what the answer would be to this.
Even or
Third goes different ways.
Oh, yeah, good. Which one of these is allowed to go negative?
Cubed.
Yeah, that one. So this one has a 0 at 0, but since it's squared, it's the same sign on both sides. It's not allowed to change signs. Does that make sense? This one has a 0 at 0, but it's allowed to change signs. That's why it's allowed to go negative. Let me stop for a minute. Which means, what does this do to that graph? What would this do to that graph?
2 to the right.
Good. So wouldn't it be exactly the same idea? It would just be sitting at 2. So what would you say? What does it do at its root? This is the root. The root is 0. I'm sorry. Yeah, Jeff. The root is 0 up here. The root here is 2. Is that cool? That's where this guy hits 0. That's the x-intercept. What does this do at its root? A very strange question, but what does it do at its root compared to this guy? What's it do at the root? In fact, what would I call this? What do we, sorry?
Like it kind of like bounces or reflects.
Bounces, I love it. Yeah, bounces, it turns, or you can use bounces, that kicks ass, right? So it's like, bang. All right, I like it. Whereas something like this, even if it's shifted, of course, that would be shifting back 4, right? It's still going to have the same idea. It's going to go through its root. I'm going to spell through with a U just so it's less letters. So here's what I can sum. And wouldn't that be the same if this was any even power? It would be the same idea. If this was any odd power, it would be the same. Become a 3 idea. Are you guys with me so far? So these are things we knew. I'm just using a little bit different terminology, and you can use bounces if you like bounces. I don't care. So if a piece of a polynomial has a root where the power is even, it will turn at that root. If it has a root where the power is odd, it will go through. This idea is called multiplicity. Multiplicity. So the multiplicity of a root tells you what it will do at that root. And again, are you guys all cool with the word root? What's the word root another name for? I am root.
Just terms.
No. It could turn or go through at the root. What's the name? What's another name for the root?
Origin.
X-intercept. X-intercept. The root is the x-intercept. So I'm going to use the word root a lot. So I'm sorry if you come from Australia. It has a very different meaning in Australia, which I found out in a weird way when I was in Australia. All right, so that's a whole other story. So watch this. If I had a polynomial that was already factored for me, what are the roots? Don't start listing band member names for me. No. I mean, what are the x-intercepts for this?
-2.
Yeah, good. So 1, 0 and -2, 0. What's the multiplicity of each?
1, 0 turns.
Okay, that's what it does. What's the multiplicity? 4. And what's the multiplicity? 3. Right, so what does it do? Let me say it like this. Behavior at the root, like you said, this would turn and this would go through. Okay, let me stop for a minute. Is everybody cool with that? Isn't that crazy easy? If the multiplicity, which is the degree of the term where a root came from is even, it's going to turn. The way I write these look like the same word. I'm sorry. There. If it's odd degree, that's an odd multiplicity, it's going to go through. So what does that mean? Okay, this is a crappy graph because we don't know enough yet to really draw it well. But with what I know, I can do this. Here's 1, 0. Here's -2, 0. Let me ask you, we even know this much. This is really the first thing I should have done. What's the EB? What's the end behavior? Does anyone remember how to get that? What's the end behavior of this
The
thing?
highest degree.
And what would that be?
7.
7.
Seventh. What does that look like?
Same as cubed. It's odd.
Same as cubed. I love it. Up over there and down over there. Now watch. You ready? We're going to refine what we're able to do. With just this much knowledge, I know it starts down here. Do you guys see that? It starts down here. What's it going to do at -2? It's going to go through. It's going to go through. Then it's going to have to eventually turn. And then what's it going to do at 1? It's going to turn. Does anybody know something we could still have done that would make this better? Because I haven't done a scale here yet, but we haven't learned everything yet. And this is really horrible. What's one more point I could get easily?
One of the vertexes.
Well,
Well, be careful. There's no vertex here at all because there's no parabola here. I understand that you think that's a vertex, but they're not really, right?
Y-intercept.
But I could find the y-intercept, yeah. And that would be one more anchor point that would help me graph this. Are you guys semi-okay out there? I mean, these are immediate things we could do. And we have a rough graph of the thing. If I found the y-intercept, it would be even better. I could then make a scale for this, right? Which obviously I'm going to need from you as an end result.
So you're saying, sorry, I forgot the exact thing you said. The multiplicity of the root determines whether or not it turns or bounces, or turns or goes through?
Yes.
Okay.
I like it. Okay. So let's do one more real quick, and then we'll talk about, how much time do I have? Not much. Damn you. Let's see. -2 x plus 1 squared times x minus 3. Sure. So what's the end behavior? Be careful. So right here, when I normally do end behavior, it's approximately something.
Third.
Say again.
Third
power. Now, what do you have to be careful about? It's negative, right? Is everybody with me? So what's the end behavior going to be here?
It'd be 1.
On this side, it's doing what? It's where?
up.
In the top left.
Up. Because it's going to be the opposite of what the cube normally is. Is everybody with me? It's going to flip it. All right, cool. What are the roots?
-1, 0.
-1, 0.
Plus 3.
3, 0, 11. So what's it going to do here? So this has got multiplicity 2 and multiplicity 1. Is that cool with everybody? There's an understood 1 up there. So what's it going to do at this one? Turn. What's it going to do here?
True.
Go through. I love it. Now do one more thing for me than we did last time. What's the y-intercept? How do you figure out the y-intercept? How do you always figure out the y-intercept? Make
X 0.
x 0. So the y-intercept would be -2 times 1, right? Times -3. So the y-intercept will be 0, 6. Is everybody? Okay. I got 1 thumbs up. 2 thumbs up. Look at that. That's good for me. All right. Now. So now I've got what I need. We're going to do more than this actually, but this is a good starting point. So now you can graph -1, 0 and 3, 0. I know I've got to go up to 6. So let's make it 2, 4, 6. My end behavior tells me where to start. So I have to start up here. What's it going to do at -1? It's going to turn.
What the heck?
Well, that was this class gets the lamest Zoom bombs. All right, let me double check. Who is Pearls? Can you change your name? Or are you a person that's supposed to be here? Who is Pearls? Hey, Pearls, if you don't tell me who you are, I'm going to kick you out. Do you understand? Pearls? Oh, good. Thank you. I'm sorry. All right. Sorry, I didn't mean to be, but if you're not somebody I want here. And Julius, I think I remember, I can't remember your last name. So, all right. That was the lamest little Zoom. I'm like, come on. All right, sorry. Now, is everybody with me so far? End behavior. This is so cool. You got to let this be cool. This tells me where to start. These tell me how to go as I move. Why does it make sense the y-intercept's here? Because I'm going to turn. Doesn't that make sense? Now, if I turn, I can go through that. And then somewhere we are, I got to turn back. What am I going to do here?
Continue through.
I'm going to go through. Shabba! There. Now we're going to do a little more than this to make a little more detail. One thing I could do is to put a 1 in to see how tall it is here, to kind of improve it here. Do you guys see what I'm saying? So the one other thing we're going to really do is plug some numbers in to see how tall it gets in certain areas. But we basically have a way to kind of quickly graph a parabola by hand. And you can always check your work on the calculator. So what I like to tell students is, if you make a mistake in your work, I want to see that mistake in your graph. If I see a mistake here and your graph is correct, no. Does everybody understand what I'm saying? Oh, Julius, you're fine, man. I'm sorry. I just get a little territorial when people come in here and do weird shit. All right. So now, hopefully, that is some motivation to, if I can factor something, I can do all this shit very easily. If it's not factored, I can't do any of this. Okay, so start with something easy. How would you factor this? What you got, Jeff? Oh, I don't know, man. Sure. Sure. Okay. That's not very pretty. Hold on. Let's do this. Make this 9 and make this 18. That's better. How do I factor that? Anybody? Grouping. Yes. Sorry. I'm not looking at the. So I group. Right. What comes out of these two?
X squared.
X squared. What comes out of these two?
9.
What kind of 9? Because I know that this has to be the same as this so that I'm able to take
Negative 9.
Negative 9. Kick ass. So negative 9 makes the signs change. And now I know I'm in the right. If these are not the same, you've made a mistake. Don't go further because you can't. So the next thing I can do is take an x minus 2 out. And I'm left with x squared minus 9. Right. And then what can I do with x squared minus 9?
X minus 3 times x plus 3.
Craziness. So what are my roots?
One, -2.
No. Oh, what? No.
Is it
What's
like
happening?
2, 0?
There's 2, 0.
2, 0. That's what I meant.
I know you meant like one, it happens once, but it's not negative. Yeah. And then you got 3, 0 and negative 2, 0. And what's it going to do with each of those, of course? What are the multiplicities of each of those?
1.
Yeah, they're all multiplicity 1. So it's going to do what at each of these?
Through.
It's going to go through. I love it. All right, I'm not going to do the rest. So from here, we could do the same thing we did earlier. But right now, I want to focus on remembering how to even get here in the first place. So here's a little bit more. Has everybody got that part? Is that all right? I'm going to start up here. So here's a little motivation for us. What if I had something like this? Oh, shit. Let me make a problem that'll work. Oh, I love it. I can go over here. Hey, everybody. What you got, Jeff? Almost there, everybody. X plus 10 plus 3x plus 10. Okay. 1, negative 6, 3, 10. 1, negative 6, 3, 10. All right, let's all pray that I did that correctly. That would be useful, Jeff. Yeah, I think so. Okay. I'm going to go with yes. Yeah, let's go. All right. Now, can I do the same thing we just did? Oh, let me see. Bowen, I'm sorry, I'm calling you out, buddy. I'm sorry. When you say, yes, exactly. So through means it goes through, and turn means it turns. Exactly. Can I do the exact same method that I just used?
Yes.
Neat. Show me. The student becomes the master.
Okay, let's do it.
Huh? So I think I'm trying to suggest to you that you cannot. Right? If you try to group, will it work? Take a second, think about it. No. I'm not sure what that means, that question. Roots are opposite of the y. Don't know what that means. You can say that a different way. Roots are just where the function is 0. That's it. That's all they are. Does everybody understand? You cannot group this. You can't. Try it. It won't work. So there's got to be a way to factor this damn thing, because I know it factors because I made it factor. I know it's factorable. All right. So let me ask you this. Whatever the answer is, what's got to be true about the numbers at the ends?
Only numbers?
Oh. Hold on to that thought there, private chatter. All right, you can do it. You can do it. What's got to be true about all these numbers? What do they all have to do? I'm sorry, this is supposed to be a cube, by the way. That's my fault. What do these numbers have to do? I love you guys so much. So if I have x plus 2, x minus 3, x plus 4, I'm going to get x cubed stuff. What's the number at the end going to be?
It's going to be a 3.
It's got to all be 10 or equal to.
Yeah, okay. Coming back to this problem, these numbers have to multiply to be 10. Wouldn't, I really need you guys, when you multiply this shit out, isn't it going to end with a 6? Yes? So then when you multiply this in, isn't it going to end with a 24 now, which is this times this times this? Yes? Yes? So what are the only possible numbers that could go here? 10 or 10 or 10. 1 or 2 or 5. Do you guys see that? Factors of 10. The only numbers that can go here are 1, 2, 5, or 10. Okay, maybe. Are you guys, is that all right? Is that, that's not that big of a deal, right? Okay, but that's great. So what I want to do then is I need to, so this is where I'm finally getting to synthetic division, because what I want to do then is say, okay, what if it's x minus 1? How do I see if that is a factor of this? Well, I have to divide it. I need some room. Okay. Right? Let me see. Let me kind of cut to the chase. Oh, yeah. All right. And by the way, it could be plus or minus, right? So it could be 2 and negative 5 and negative 1, right? Anything that multiplies to be 10 at the end. Okay. So let me cut to the chase a little bit. Let me put a 1 here. All right, now if we long, just go with me. If we long divide, x times what is x cubed, x squared. X squared times x is x cubed. X squared times 1 is x squared. And then who remembers what I do next? What do I always do in long division? Right here.
Sign.
Change the sign. I subtract. I like change the sign. So these cancel like they have to. Negative 6 minus 1 is negative 7 of these. Bring down the 3. X times what is negative 7x squared?
Negative 7x.
Good. Negative 7x times x is negative 7x squared. That's amazing. Negative 7x times 1 is negative 7x. And then I subtract, change the signs, right? This is how you long divide. How do you long divide these, Jeff? The same way you long divide numbers, because that's what these are. These are just numbers. 3x and 7x is 10x. Bring down the 10. This is looking good. X times what is 10x? 10. 10 times x is 10x. 10 times 1 is 10. Change the signs. It went in even. Yeah. See, the remainder is 0, meaning that is a factor of this. Now, why was that quick? Because I already knew that was part of the answer. But if you did not know that was part of the answer, wouldn't you have to check every possible number? Wouldn't you want a shorter way to do this shit? Isn't this a long problem, even though it's a relatively not many numbers going on, right? This is long. Can you identify what parts of this thing are not necessary, like this? Is it necessary to keep writing this because it's always going to cancel? Isn't that bullshit? Aren't these the important parts? 3 and 7 makes 10. I mean, those are the important parts. Do you guys understand? No. All right. Isn't there a lot of writing here that ends up being unnecessary? Yes, there is. So here's the synthetic. So I'm going to do this up here, and then I'm going to show you the handout I put up on Canvas about synthetic. Here's what synthetic does. And here's the one part that sucks is having to remember to change a sign. That is something students always forget, to remember to change the sign. So what synthetic does is it says, all right, let me not write any stupid x's. Let me just write the numbers. That's really all that matters, are these numbers. And the very first thing I'm going to do is I'm going to change the sign of this so I don't have to change the sign every single time. I just do it once at the beginning. So I'm going to put a -1 here. Then I'm going to write. So I'm only writing the numbers, not the variables. So what are the numbers over here? What's the coefficients?
1.
Yeah, so 1, -6, 3, 10. All right, now watch. Whatever number is here, isn't that going to be part of the answer? Like if there was a 2 there, wouldn't I have put a 2 there so that it would multiply? Same way there was a -7 here, there was a -7 there. Okay, maybe. So watch this. This is kind of nice. I bring the 1 down. So this is going to be the coefficient of the answers. So bring the 1 down. Now watch. That corresponds, oh, let's see where I want to go. Yeah, that corresponds to this one right there. -1 times 1 is -1. Now I'm right, you see, -6 and -1. So I'm going to add these, -7, multiply. So I multiply, put the result, add. Multiply, -1 times -7 is 7. Put the result, add. -1 times 10 is -10. So I put the result here, and then I add. You guys see how I got exactly the same? I got a 1, and then a -7, and then a 10, right? Do you guys see that at all? No? So can you see -6, -1? That was the important piece. -6 minus 1. 3 and 7. 3 and 7. 10 and -10. 10 and -10. Those were the important parts. This thing only picks out what's important. What did it start off as? Cubic. So when I divide it by x, these are going to be the coefficients of 1 power less. So if it was x cubed, these are now starting at x squared. So x squared minus 7x plus 10. Synthetic division. So I got a really good question. Synthetic division only directly works when you're dividing by 1x plus a number. This is the only time, and this number could be negative, by the way. You guys with me? So it's got to be linear with a slope of 1. So if I was trying to divide something by x squared minus 7, I can't use synthetic division because it's not linear, the thing I'm dividing by. This is so freaking cool. This takes this mess and makes it really, really quick. All right, so let me show you the handout, just so you know you're not having to rely on my disgusting writing for your notes. Let me show you what I got up here. What time is it? Mouse, wake up. Oh, shit. All right. So let me show you this. Oh, man. No, I'm quarantining. Why am I having a cold? Shouldn't be allowed. All right. So if you go to your modules, let me become a student so it looks the same. Become a student. All right. And you go down here, right underneath function writing is the long and synthetic division. And on this, I've got an example of long division. And then down here, I do that same problem again with synthetic division. So I don't like hockey. I don't really watch hockey, but I call this the penalty box. I don't know why. So in the penalty box goes the root associated with this, right? You change this guy's sign. That's related to changing the sign each time, but I just do it at the beginning. That's awesome. So if I just do it once at the beginning, I don't have to do it every time. Oh yeah, let me show you again where it is. So modules, go to chapter 5, unit 5. There's the function writing one we just did earlier, and there's the long and synthetic division. So I do an example of long division. I do an unrelated example of synthetic, just to really show you, look what I'm doing. Bring down the 1, multiply by -3, add, multiply by -3, add, blah, 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 blah. Okay. Blah, 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 blah.
That makes it so easy.
I know. Let me ask you this. Later this semester, we're going to do something called matrices. We're going to work with matrices. Have any of you ever worked with matrices before?
Last semester.
Yeah, I did too.
All right. Now, people normally kind of hate matrices because we do a lot of shit with them. You with me? But the one thing this has in common with matrices is it takes all the variables out of something and focuses on the coefficients, because that's all that really matters to get to the answer. That's why long division is so freaking long, because I'm keeping track of all the variables. I don't need those. I just care about the coefficients. I want to get the answers, the coefficients for the parts, right? So that's why this is more streamlined. And of course, that's why it doesn't work all the time. It is so streamlined because it only works when I'm dividing by 1x plus or minus something. Okay, so we basically just did 2 sections, believe it or not. And that's why it felt like a lot, because it was. We did 5-3 and we did 5-4. That's what we just did. So you can look at the book too. I haven't looked at the book here in a while. It does an okay job with the, it does an okay job with the long division. I can't remember how, here's synthetic. Yeah, okay. You can't really mess that up. So it does an okay job with synthetic. So you can look at the book to get some more examples. But hopefully you guys get the motivation. Now, do you understand? Synthetic division is a really strong factoring tool. You can factor so much more now with synthetic division. And I know some of you guys are like, yay. But my life is complete now, Jeff. Thank you. But it's going to be important for this class. So hey, what the hell?
I have a quick question.
Yes.
Where or when rather will you be posting the 5 homework so we can start posting that to you?
Oh shit, have I not opened those up yet?
No.
All right, so I'll do that right now. Any other questions, guys? Let me see.
Yeah, mine.
Huh? Yeah? What?
Hold on, I'm trying to pause my show so it doesn't play in the background.
Okay.
Okay, so the roots. So I understand that they are the X-intercept, but how do you come up with the root? Because like all the examples you were going over, like one of them I think was like what I wrote was 0, -2, and then you said the root was 2. I think that's the same one.
All right, so there's a major thing going on here. Look at this problem up here. All right, real quick, everybody stay with me, stay with me. If we finish this problem out, watch. What do we know so far with this problem? We know that x plus 1, so I know that f of x plus 1 went in evenly and it left me with this. So that's what this means, right? Yeah. This divided by this is this. So that means this is equal to this times this. So can't I break this up even more, right? This is easy to factor now. Is that cool?
Yeah.
X-intercepts, which are also called roots, are what you get when you make y 0. So the y will always be 0.
Oh, okay, so I see. So if it was a -4, it would be 4. If it was a 4, it would be -4.
Yeah, because you're making the 0, which means you would subtract 1. That's why it's -1. Or you just think -1 would make this 0. 5 would make that 0. 2 would make that 0.
Gotcha. Okay, I see now. Thank you.
That's why if you break it up into little parts, you can just pick out the roots real quick.
Yeah, that's simple. Okay, thank you.
You're welcome. And of course, then you know multiplicities, and then and then you can graph it pretty quickly after that. I mean, so you would have never thought we could have taken like an x to the 5th, and we can use synthetic division. We can break it down into its parts. We can find the roots. We can do the multiplicity. It's relatively quick. quicker than you
Yes.
thought it would be to graph an x to the 5th with all its parts in there by hand.
Definitely.
Yeah. So this is kind of cool. Hopefully a few of you guys feel the same way. Even if you don't, you still got to be able to do it. So, all right, guys, that's enough. Let me know if you have to, if you want to hang out afterwards. Otherwise, you are free to go.
Thanks, Prof.
Anytime, dude. We
Have a nice
survived.
night.
You too. You survived another Zoom bombing. Good job, everybody.
Have a good one.
You too, Austin. Everybody is okay? I'm going to head out. I'll see you all tomorrow.